All right. So one of the important things about the periodic table is that it's predictive power. This is a big thing for science. We want to be able to predict things. So what I've got here is a list of elements in their positions in a periodic table, and the charges that these elements adopt when they become ions. So calcium, for example, is not always an ion. You can also find neutral calcium. But when you find it as an ion, it is +2. Same thing for oxygen. You can find neutral oxygen atoms, but when oxygen is an ion, it is a -2 ion. So does anything jump out at you with this? So a couple of things. Metals. So here, this red line here is sort of the classic dividing line between the metals and the non-metals. And they have very different, almost diametrically opposed chemical properties. The chemistry of metallic elements is dominated by their tendency to lose or give away electrons. The chemistry of non-metallic elements is dominated by their tendency to gain or take away electrons. Now, so if you will look here, the ions that I have highlighted here, or the elements, I should say, that I've highlighted here, consistently the elements that are in the same column all have the same charge. First group here, they're all +1. These are all +2s. We're going to talk about these in a second. Now, starting from the other way, we go from the edge in. The noble gases, so helium, lithium, not lithium, helium, neon, argon, those guys, they really don't like to form ions. But next one's in. Fluorine, chlorine, bromine. They're quite happy to form ions. When they do, it's -1. And next row in, -2. Next row in, -3. So you can kind of see that each time you are changing by one more. So here, +1, +2. If you ignore this in the middle, now we've got +3. If you want to think about it this way, 0, -1, -2, -3. Now, I know you are wondering, and in a future part of this class, but because it's here right now, ions that behave like this, that adopt a single charge, that is predictable from their position in the periodic table, I like to call type 1 ions, which implies there's another type, type 2. And so the ones in the middle are not as easy to predict. Now I'll get to that in a minute. And moreover, the other complication is some elements, such as iron and copper and gold, can actually form in 2 stable charge states. And this is quite common for elements that are in this middle. We call them transition metals. And so these we call type 2 ions, if they can take up more than one charge. Now note that there are a couple of type 1 ions hidden in here. So for example, silver, cadmium, and zinc only adopt one charge, +2, +2, and 1 for those guys. Now these are still metallic elements, so they still form positive ions, cations, but the magnitude of the charge you can't easily predict just from where it is in the periodic table. The charges are usually between +1 and +4. Is good, and anything beyond that's not really energetically feasible. And so while I've got this up here, I want to show you a couple of other things. Often these groups, the columns, have names, and you'll be expected to know a couple of them. The first one is this first group all the way on the left. So these are called alkali metals: lithium, sodium, potassium, rubidium. And again, that name applies to both the neutral and the ionic form of the element. The next group in are referred to as the alkaline earths because these elements, when present in rocks or soil, tends to make it alkaline, not acidic. Going back on the other side, we are talking about noble gases, so that's helium, neon, argon, those guys. The next one in, group 7A or 17A, and some are called the halogens. So that's fluorine, chlorine, bromine. Now this is a little less common because in grad school I had a roommate that studied these. I had to learn this word, and then by extension you all do now too. The next group are called the chalcogens, so that is the sulfur, oxygen, selenium, tellurium group. So make sure you know those names and what elements constitute those groups. Now, the next thing, the last thing we talk about is what's to deal with these charges. Now, clearly, something's got to be going on for this pattern to happen. And the pattern becomes a bit evident if you look at not a periodic table, but a periodic cylinder, where the headline here is Group 8A, the noble gases. Now, we will find out, unit after next, the number of electrons that the noble gas elements have. 2, 8, 2, 10, 18, and so on, are sort of magic numbers. And that for an atom to have that number of electrons makes it particularly stable. And what's happening is these various elements are losing or gaining electrons to mimic those numbers of elements. So for example, fluorine. A neutral fluorine atom has 9 electrons in it. Neon has that magic number of 10. So if it picks up 1 and only 1 electron, it goes from 9 to 10, has the magic number, it's quite happy about that. And if it gained more than 1, then you would have 11, and that's less happy. So this is why oxygen, adopts when it does a -2 charge. It normally has 8 electrons, and so it's too shy of the magic number of 10, which is why when it forms an ion, it picks up 2 and only 2 electrons. Now look at the other end of it. So sodium is element number 11. So a neutral sodium atom has 11 electrons in it. It has 1 more than the magic number 10 that neon has, or it has 7 less than argon, having the next magic number of 18. So if it wants to get one of those magic numbers of electrons, it can either lose 1 to become neon, or pick up 7 to become argon. And losing 1 is a lot easier to pull off than gaining 7. So this is why when sodium forms an electron, or an ion, that it is always +1. Likewise, magnesium is 2 over that magic number of 10, or 6 under that magic number of 18, so it's going to lose 2 to mimic neon, and will not pick up 6 to mimic argon. And so this is why these elements here form the charge that they do. They are doing that to mimic the number of electrons of the noble gas in the row above it. And so that's why these charges are predictable, but do keep in mind that applies only to these elements that are at the outer edges, the outer 2 or 3 rows of the periodic table. But that is something you'll be expected to be able to do for those elements. All right, that's it. We will see you next time for the next unit.